Hello and welcome to this video on Pydantic. So Pydantic is a library in Python that is used for data validation so that you can work with data in an OOP manner. So Pydantic has type hints for schema validation, so you get type safety and auto-completion, so data has defined types. And you can use it for input validation. So if, for example, you take data from an API and the API changes or it returns invalid data, the Pydantic will raise an error. Models become self-documenting with expected structure of data. So it's easier to test a class than a JSON object. You can deserialize the JSON string into a Pydantic model. You can serialize a Pydantic model into JSON, so you can go both ways. And in this way, it will be very easy to work with data and make sure that the data is correctly validated. And of course, we have learned how to create our own validation for our methods and properties. However, by using Pydantic, we get a lot of validation for free and make sure that the type is correct. So we don't need to custom write our validation in most cases for the data. Yes, so let's move on to Visual Studio Code. So here I am in Visual Studio Code and I'm in an empty folder, and you should definitely be in an empty repository and where you can commit and push your code. So here in this empty repository, I will just create a virtual environment. And if you already have one, don't do this since this will overwrite the old one. And we'll activate it, source.ven bin activate, and with Windows is with script instead of bin. And now let's install Pydantic, uvpip install Pydantic, and I will need ipykernel as well, as I will work in Jupyter Notebook. Okay, done. Let's create our Jupyter Notebook. So touch Pydantic basics.ipnb. And for this, we will work with some JSON data. So let's see, Pydantic. And in order to get the JSON data, I will, instead of providing it directly, I will use an API. So we need to install that as well. Source.ven bin activate, uvpip install requests. So we need requests in order to get data from an API. So now I think I don't need this anymore. Okay, I will copy this code and I will leave the link in the description. So what it does is that we get this link to Poke API. So it's a Pokemon API to get the Pokemon data, basically. Okay, so I will leave this link, import request, or actually you can see the link in my code repository. So if I run this one, you can see that we get the count, next, previous results for our data. So data, it looks like this. It has count 1302 and it has a lot of result. You see it's a list. So this is the JSON data that we get back from doing a GET request from this API. Okay, so we could do data.get result. Let's say result like this. And we get the results. And if I do length of it, actually we can leave it like this and we can copy this one and we do length of this one and it gives 20. But how come the count before gave 1000 something? That is because I have a limit here of 20. So if I do, for example, data of count, then you can see 1302. Okay, so let's move on. Actually, I don't want to print all of yeah, it's okay, fine. Let's move on. Now we'll use Pydantic to read this data in. So using Pydantic to deserialize the JSON object, JSON string into, or JSON object into pick model. Okay, so let's see what this means. So we need to, from Pydantic, import base model. So it's to create a Pydantic model, we need to inherit from the base model. So basically like this: class Pokemon list response. I call this class like this, and then it inherits from base model. So it means that it becomes a Pydantic model. But it is still a class, right? It's still a normal Python class. It's a Python class that has extended or inherited from the base model, which makes it into a Pydantic model. Let's see, before we run that one, I will run data of results like this, and I want to have a :5 just to see the structure. And as you can see, you have the name and you have the URL. You have the results as a list, and it's a list of dictionary. And also you have data of count, right? And this is an integer. So this is what we expect. And as we expect this one, so results, and these are the ones that I want to represent in my Pydantic model, because in this case, I don't care about the other keys. So I don't care about previous, I don't care about next. So for this, I just want to have the count. So count is an int, and let's see, yeah, let's don't do that for now. So count is an int, and we have results, a list of dictionary. So that is it, and now we have a Pydantic model. So let's create this. So Pokemons equals to Pokemon list response dot model validates data, and we can see how our Pokemons look like. So our Pokemons look like this. So we have count, it wasn't right. So we have 1302. And then we have results is this list of dictionaries. And you can see that this is the Repo, right, of this Pokemon list response class. So if I take type of Pokemons, you can see that this is a Pokemon list response. So this is a class. And we can use this as a class. We have different fields, right? So these are the fields. We have count, we have results. And then we can use Pokemons and use the dot notation. We can get the count, for example. You can see this is the count. We can do Pokemons dot results. And we get the results like this. However, if we get the wrong data types, the data comes in. So if we get the wrong type or the wrong data comes in, or the API changes, let's see what happens. So for example, I will copy this part here. For example, we have string instead of int for count. What will happen? So I run this one, and you can see there's an error. Let's clean this up, doing try. Let's see, except, and this is a validation error. So validation error you get from Pydantic.errors, import validation error, Pydantic validation error, like this. Validation error as error, print error. Okay, so this is what you get. One validation error for Pokemon list response, and it says it's the count. Input should be a valid string. Type equals string type. Input value equals 1302. So input type is int. So as you can see, it's an int compared to what we require. So we require it as a string type. That's why we get this error. So you can see you get a very neat error message whenever the API changes. So for now, we simulated the API change, but actually we changed the model. So we want to have string. So we get the type validation for free here using Pydantic. So this is really useful. So let's take another example. I'll copy this code with this URL, but you will get that also since this code will be in the GitHub repository. So data.keys. Let's see how this one looks like. So if we look into the data, what do we have? So this is the data for Pikachu. So it's the Pokemon species here. So we have the keys, we have base happiness, capture rate, color, egg groups, etc. So this is how the data looks like. Okay, so base happiness, we have 70, capture rate 190, etc. So just to check what classes we have, we could do it like this. So for key common values in data.items, and then just print out an f string key colon values so that we have space, and then we have type of values basically. And I run this one, and you can see here base happiness int, capture rate int, color, egg groups, list, etc. So this is what we get. And using this one, I want to represent a few of these as fields, but I don't want to represent all of them. So what we do is we create class Pokemon. It inherits from base model, and we can do ID is an int. Let's see ID here, it's an int. Do we have some name maybe? Here we have name as string. So we have name colon string. Let's take the happiness. Base happiness as an int. Capture rate. Capture rate is also an int. Capture rate as an int. So these are type annotations, right? So type annotations, but for Pydantic, it enforces the type. While if you know about data classes, you also use type annotations like this to create fields. However, if you put in the other types, it's still okay for the data classes. It won't give an error. While here in Pydantic, it makes it into strict, so that we need to conform with the type, need to conform with the schema, right? So let's continue here. Let's see, what do we else have? Evolution chain, maybe. Just copy that one. And this is a dictionary. Evolution chain is a dictionary, right? And then we have gender rate is an int, and we have generation is a dictionary. Okay, and now let us take Pikachu equals to Pokemon and dot model validate, and we want to validate the data, and then we can look into Pikachu, how that looks like. Okay, now we have some data here. We can see, okay, ID is 25. Yes, 25 in order. It is base happiness, 70, blah, 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 evolution chain URL. So if I click into this evolution, we can see this is what I get. This is a URL from that. So I can print out the ident and indented code. So maybe here we should evolve to, let's see, do we have Raichu maybe? Yeah, the name is Raichu. It evolves to. Do we have Pichu somewhere? Yeah, Pichu is baby Pichu. Okay, good. So this is the Pydantic model that we have. So what can we do with this? We can do, for example, Pikachu dot, let's see, dot evolution chain, and you can see, yeah, it's a URL here. We can do Pikachu dot generation, and you can see, yeah, this is generation I, and here's a URL for that. So it's also a dictionary. Okay, so when you have this, say that we have a object that we have been working with, or this one, we have been working with this one, and now we want to be able to give out a JSON object, because for different reasons, for example, we're creating an API. using, for example, Fast API, which uses Pydantic in the background, or we are, for some reason, we want to output JSON data from our object. So we can do like this. So Pikachu model dump JSON, like this. And here is the JSON object, as you can see, as a string. So this means that we have serialized this one. So remember, we take from JSON object into Pydantic model, we deserialize. When we take the Pydantic model and output as a JSON, we serialize. So now we serialize. And for this, we can call it serialized Pikachu, for example. So an example of an application for this could be like, oh, you're sending in to search for a certain Pokemon by name. Okay, and then I could send in that to the API, and the API picks out all this data, right? But I only want to output this part. So then I deserialize first, and then I pick out the ones I want, I validate so that it's correct, then I serialize it so that I have this JSON object. And then I can send it in, for example, an API to an end application. So we can check the type of serialized Pikachu, and you can see it's a string. We can see that by the quotes here. And we can also print. We can print out the serialized Pikachu, and you can see it looks like this, but it's not easily readable. However, we could do like this print. Let's see, Pikachu dot model dump, right? Dump JSON, and we can do an indent. If we just do dump JSON, this is the same as the serialized Pikachu, but we could do indent equals to 2, for example, and you can get the indentation that looks like this. That's quite neat. Okay, so you've seen this lecture of using Pydantic. So it's a basic Pydantic where we've just taken data from an API using GetRequest with the requests library. And then we have an object into a Pydantic model, which is a Python class, which has this type validation. And then we've tried out to make the class type not conform so that we have, for example, string that we require, but we get an integer. So this created an error. So Pydantic gives a very good error so that you know that something is wrong with the data, or the API may have changed, etc. And so it's important to validate this. And then afterwards, we did the serialization. We took out a few fields and deserialized the data into Pydantic model. And then we serialized that part into JSON and chose to also do some indentation to see how it looks like. And so this is a neat way to work with data in an OOP way. And I hope that you learned a lot from this video, and make sure to commit and push your code, and then see you in the next video. Bye.